Hello, everybody. Today we're going to be talking about an analysis of part practice and whole practice. To understand this topic, we're going to have to talk about what is practice and how is it different from play. Practice is specifically something that is structured and designed to improve ability at a skill. The benefits of practice are showing improvement during play. Two things that are going to kind of factor into this are Fitts and Bernstein's stages of learning. Fitts stages of learning starts out with the fixation or a verbal cognitive stage, and this is basically the participant talking through something, thinking about a process, working to understand the movement that needs to be done. Then we'll go to a fixation stage where they're focusing more on it, a little bit less talking or thinking. They're just working through the movements. And then finally, you'll hit a automatic stage where the movement becomes automatic, easy. They can do it while having a conversation with somebody, for example. In Bernstein stages of learning, it's all about moving through and reducing and releasing degrees of freedom. So you'll start out by reducing the degrees of freedom, and that just basically means cutting out non-essential movement of muscles, joints, limbs. And then you'll release degrees of freedom, which is the smoothing out of a process. And then you'll exploit passive dynamics, and this could be an example of not pedaling when riding a bike downhill because gravity is helping you complete the movement. The two main things that we're looking at, like I said, are part practice and whole practice. Um, these are each beneficial for different actions. Part practice is more beneficial if the components of a skill are not highly interactive, uh, where whole practice is better when they are highly interactive. Uh, that component interaction is how much things are tied together. Like the movement of a golf swing, it would be hard to separate that into individual segments because it's all one movement typically. You could perhaps split it up into a backswing and then a forward stroke, but uh, it might not be as effective as just doing it all at once. The purpose and hypothesis. This is important in motor learning because it helps us understand uh, how we can learn best and what's the most optimal way to practice. This can be used by coaches, physical therapists, medical professionals. I mean, it's applicable across a wide variety of careers and fields. And then the hypothesis for this is based on the principles of component interaction, we would expect whole practice to be more effective when learning to juggle because of it being highly interactive. For the method of this lab, the setup was to have two participants, and they're gonna one of them is gonna be juggling using whole practice. So in each block, they're gonna juggle 3 balls and try to go as many rotations as they can. And specifically, we're tracking catches of a ball. The part practice one will have their task broken down into 3 stages. First, they're going to toss one ball to the other hand repeatedly. Next one, they're going to add another ball. And then finally, they'll do a third ball before doing a retention test. And both of them will then do uh, complete juggling and see who can do the best. And then, like I said, the data that's being collected is going to be the amount of balls caught. And for the results, part practice was recorded as having an average of 5.07 balls per attempt. This is contrasted to, or compared to whole practice, which had an average of 6.17 balls per attempt, or an increase of 1.1 over part practice. This took into account 34 data points, and the p-value was recorded as 0.03. And expectation versus results. So we expected the whole practice to be more beneficial when compared to part practice uh, due to the highly interactive nature of juggling. It's very difficult to separate the process and then recombine it back together. Um, and the data showed this. Part practice, like I said, was 1.1 lower than whole practice, which is in line with what you would expect. And you can see on the graph we got there the difference between the two practices. Uh, the p-value, as I mentioned, was 0.03. This is significant because a p-value of that number would show that it is that it's significant. There's a high degree of likelihood that this was not just random, um, and it would indicate that the numbers are good. Um, so, in conclusion, part practice is more beneficial for less motion, and whole practice is better for highly interactive motions. And the resources cited for this is going to be Motor Learning and Performance from Principles to Application, and that's by Schmidt. Thank you for your time.